Okay, so let's take a look at this one. This is 2011, question number 4. So we have our ball in our beaker with our water. They give us a lot of information here. And let's go and do it. So calculate the weight of the entire apparatus. So the weight of the apparatus, the whole thing, should be the weight of the beaker plus the weight of the water plus the weight of the ball. So just kind of the sum of all three of those things, right? So the weight of the beaker, do we know that? 2. Plus the weight of the water, do we know that? Not yet. So we'll write mg of the water. And the weight of the ball, do we know that? 3. Okay? So we do have to find the mass of the water, right? So that's kind of one of the tricky parts on this, but we do know that they give us the density, right? They give us the density of the water. What's the equation for density? Mass over volume, right? So the mass of the water should equal the density, which is 1,000, times the volume of water, which was 5 times 10 to the negative third. Okay, which is simply 5 kilograms. So the water is 5 kilograms, therefore what is the weight? 5 times 9.8, so that's 4.9. So 2 plus 49 plus 3 equals 54. Okay, so this was worth 2 points only. So basically 1 point for the setup, 1 point for the answer. Yes?
If we use 10 instead of 9.8 for figuring out 55, we use that.
It says you're going to get credit for using 10. I would in general, because it's you have a calculator for this, I would go ahead and just use the 9.8. But for multiple choice, definitely you want to be using 10. Alright, on the dot, draw the forces. Okay, so we're just going to go ahead and draw the forces here. We're going to have mg coming down. Right? So I'm going to write force of gravity. This is on the ball, right? So force of gravity coming down. We have tension also coming down. We'll write that as Ft. And then what's left? Buoyancy force. So we'll have our buoyancy force Fb up. Okay, so 3 points. Basically, if you have all three, 1, 2, 3, you got 3 points. Okay, so if you got the first two right, you got 5 points. Remember, we're looking for 4, 6, and 8. 4 to get a 3. So if you've already gotten a 5, you got a 3 already. Letter C, find the buoyancy force. Please note that it says do not draw anything back on the diagram. So this is not really an issue on this particular problem, but occasionally, let's say you have a problem like a inclined plane or something, and you draw your forces like this, right? And then like when you start to solve the problem, you might break it down into its components. What you don't want to do is do this kind of stuff on your official answer. So you leave your official answer alone, and then if you need to draw in components or do other things, do that separately. Okay? Okay, anyways, letter C, what are we solving for? Buoyancy. Okay, now you do have your buoyancy equation, right? That's Fb equals rho gh. No, it's not rho gh. Rho gb. Okay, but does that help us in this problem? No, because what? You don't know the volume of the ball. So be careful, this is not the volume of the liquid, which they do give you. This is the volume of the ball itself, or it's specifically the volume submerged, which in this case is the whole thing. But you can use this, okay, because this is an equilibrium, right? So when you sum up your forces, you have Fb minus Ft minus Fg equals Ma equals 0, because it's in equilibrium. So in other words, Fb is simply going to be Ft plus Fg. And this is the Fg of the ball. Okay, were both of these given for us? tension was 4, right? And Fg of the ball was 3. Equals 7. Okay, now I don't know why they only gave you 1 point for that. It seems like a lot of work for 1 point, but that's all they gave you. So that means we're up to 6 points. Letter D, find the pressure due to the liquid, the gauge pressure at the bottom of this. So how do we find the pressure at the bottom? So this one is where we go, well, if you look for absolute, what's the absolute pressure? But if we're just looking for the pressure due to the water, we don't have to include the atmosphere, right? So we're only going to do rho GH. So P should equal rho GH. So rho was 1,000, G is 9.8, and H was 0.2. Okay, so what's the answer for that? 1960. Now what are the units for pressure? This is important. Pascals, good. Or you could have done newtons per meter squared. So I do want you to notice, here's the rubric for this. They do say correct answer with units. So make sure that you're including the units, otherwise you're not going to get points. You're not going to get that second point. So that one was worth 2. Anyone 8 for 8 at this point? Only a few of you. How about 6? 6 for 8? On your way to a 4 or more. Let's see how we do this. What happens when the string is cut? The ball rises and floats. What happens to the water level? Higher, lower, equal. Lower. Okay, it will be lower, right? Why is it lower? Because right here, the whole ball's submerged, right? So some of the water is going to, like you've all done this before, if you put something underwater, you get in a bathtub, right? The water level goes up. Well, if only half of it is underneath the water, the water level is going to sink a little bit, okay? Because not all the volume is submerged underneath. All right, so 1 point for saying lower and 1 point for that kind of explanation. Let's see what they said. They said less fluid is displaced by the rubber ball because less of the ball's volume is submerged in the water. So some kind of explanation like that. Okay, so give yourself a score. How many people got at least 4? Okay, see, everybody's going to pass. That's all you need.